All right, so I apologize that I wasn't able to get all of this into that last video, but again, this is our last little bit about ionic bonding. So the last little bit is about polyatomic ions. So poly means many and atomic means atoms. So polyatomic ions are ions that are made from more than one atom. So everything we've talked about so far only has one atom. These ones are going to have multiple. So what's cool about the polyatomic ions is that the names and the formulas don't change, okay? Which that'll explain more in a second. And if you need more than one polyatomic ion, you put it in parentheses because it goes as a whole unit. So what I want you to do is to write these carefully on the back of your periodic table. Okay, so the ones I would like you to write on, hold on. I want you to write on the back of your periodic table are right here. So if you want to write carbonate, hydroxide, nitrate, ammonium, sulfate, and phosphate. Now you need the symbols along with the charges. That is very, very, very important. So this is what I meant by their formulas do not change. Carbonate's formula is CO3. That's what it is. It goes together. You cannot get rid of that little 3, okay? It goes together. That's like calcium getting rid of the A. That is the symbol for carbonate, is the C with the O and the 3, okay? And all of the C and the O and the 3 together give you a -2 charge. So put those on the back of the periodic table. That is not all the polyatomics, but that is those are the very common ones that we are going to use, all right? Perfect. So now how you're going to use these, what I want you to kind of look at is we're going to try and name these. And so remember, their names do not change. So how I'm going to name this is Na is just sodium. And OH, remember, if I look in the back of my periodic table now where I just put up my list, is hydroxide. Now look, there's no numbers, there's no middle name, it's just 2 words again. So I know that I need to be looking for polyatomics and be flipping my periodic table and looking over on the back. I know that there's a polyatomic here because look, there is 1, 2, 3 different elements. Okay, you know different elements by how many capital letters there are. Everything we've been working on so far, we've only had 2 elements. Okay, now we have 3. So when you have more than 2, you know that there's going to be a polyatomic. So same sort of thing here. 1, 2, 3. Oh, there's 3 elements. I should be looking and knowing that one of them is my polyatomic. So Li is lithium. It does not matter that there's 2 lithiums. Okay, remember there's no numbers. SO4 is sulfate. Oops, I can't spell. Sorry. Sulfate. Now I'm not putting any numbers in. Again, remember I'm not doing a 2. I'm not putting the 4 here. Please do not do that. Okay. Same sort of thing down here. 1, 2, 3. 3 different elements. So we're going to have magnesium. And then NO3 is nitrate. So what I see happens is sometimes people get going really quick and they're like, oh, nitrogen, nitrate, nitride, and they get everything messed up. So remember that nitrogen is just regular old N. Nitride is when we're doing ionic bonding, so nitrogen changes to nitride, but nitrate is NO3, okay? So that's kind of nice, the names don't change. Now we're going to write the formulas for them. And when we write the formulas for these, it's the same sort of thing. Aluminum is a +3 charge. It's Al for its symbol. Carbonate now is on the back of our periodic table. It is a -2 charge, and the symbol for carbonate is CO3. That is the symbol. You cannot get rid of the 3s. What I see happens a lot is people don't put that 3 on there and they just write CO. You cannot do that. It is just 3 of them, okay? Now, what is the lowest common multiple? It's just like ionic bonding before. The lowest common multiple between 2 and 3 is 6. 3, right here, aluminum number 3, needs 2 of them to get to 6. So I need 2 aluminum. So I'm going to put a little 2 there. Carbonate is a -2. In order to get to -6, I need 3 of them. So I'm going to put a little 3 down here. This is what I see happens. So is that correct, do you think? And no, it's not, because that's saying you need 2 aluminums, 1 carbon, and 33 oxygens, the way I have that written. So if I go back, look at my rules here. If you need more than 1, you must put in parentheses. So that's my rule. I needed more than 1 carbonate. I'm putting carbonate in the parentheses. So now it's saying I need 2 aluminums and 3 carbonates, okay? So if I were to count atoms here, that's 2 aluminums. This 3 distributes to everything inside, so it's 3 carbons and actually 9 oxygens, okay? Now sodium, let's do another one. I'll do it in a different color. Sodium is Na. It's a positive 1. Remember, I'm just getting charges from my periodic table that we've already written down. You don't have to have this memorized. Phosphate now is on the back of my periodic table. It's -3. Its symbol is PO4, okay? The lowest common multiple between 1 and 3 is 3. I need 3 number 1s to get to there. I only need 1 phosphate because phosphate is already -3. So I'm golden. Na3PO4. Now the last one, beryllium hydroxide. Beryllium is Be. It is a +2 charge. Hydroxide is an OH. It's a -1 charge. Now the lowest common multiple between 1 and 2 is 2. I need 1 beryllium because it's already at 2, so I don't do that. And I need 2 hydroxides. So I put a 2 here, but remember you have to put it in parentheses. If you don't, if you just write BeOH with a 2, you could switch that around to BeH2O. That's beryllium water. That's not beryllium hydroxide. So just be really careful that you're putting the parentheses in the right spot. All right? Now, again, this will be in your key later, okay, that I'll post on a little bit. But let's just try out a few of these. So ammonium is on the back of my periodic table. It's a +1 charge. It's NH4. Chloride is a -1 charge, and it's Cl. +1, -1, it already cancels out. I'm golden. Sodium is a +1. Phosphate is a -3. Sodium is Na. Phosphate is PO4. The lowest common multiple is 3. I need 3 sodiums there and only 1 phosphate. Calcium is a +2. Nitrate is a let me check, I don't remember, a -1. Calcium is Ca. Nitrate is NO3. Lowest common multiple is 1 and 2. I need 2 nitrates here. Okay. Same sort of thing here. Barium +2. Hydroxide -1. BaOH2. And aluminum +3. Sulfate is a -2. So it's going to be Al2 SO4 3. Okay, now down here you're just naming. It's kind of nice. There's 3 elements, so you know you need to be going lithium phosphate. NaNO3 is sodium nitrate. Okay? And so on and so forth. I skipped around on the ones before. Oh, oops, sorry. I'm going the wrong direction. My bad. What I'm going to post now, this is an Ionic formula writing practice quiz. I will post that onto the Google Classroom as well, along with the key, so that you can practice, okay? And then you would take the quiz. Okay, so make sure that you do the practice quiz beforehand, and then do the regular quiz. So here's a practice quiz. I will also post an actual assignment one for you to do as well for points. Before I do that, because now we're kind of done with ionic bonding, I want to scroll back in the notes for these ones that I skipped before and kind of just walk through them with you. So potassium bromide, these are the ones again we skipped before. Potassium is a +1. Bromine is a -1. It's just KBr. Aluminum is a +3, oxygen is a -2, so it's Al2O3 in case you're having issues with these. Calcium is a +2, sulfur is a -2, they already cancel out, CAS. Iron is a +2 because it says so right there. Phosphide is phosphorus, it's a -3. Lowest common multiple is 6, so it's Fe3P2. Lithium is a +1, nitrogen is a -3, so it's Li3N. Okay? Now for naming, pretty easy. Barium, chloride. My L got kind of short. This is rubidium, oxide. This is aluminum, iodide. It's a weird one. Fr is francium. And right in here is iron. O changes to oxide. Now, this one would have been wrong, right? Because iron, you need to have a transition, is a transition metal, you need to have a Roman numeral. So how you figure this out? You got to look at the opposite one. So look at your oxygen. Oxygen's a -2, but there's 3 of them. So it's a total of -6. So you need a total of +6 to cancel out that -6. But there's 2 irons. So what goes into 6 2 times? And you get a +3. So this is iron 3 oxide. All right, now hopefully after all of that, in your practice problems and your practice quiz and the real quiz, this will help you deciding how to do ionic bonding. After you take the ionic bonding quiz, you can then move on to the covalent stuff. All right, thanks. Let me know if you have any questions.